Hello viewers, in today's session we are going to discuss another important problem from application of derivatives. And here we are going to take up one problem from increasing and decreasing functions. And here we have to prove that this function f of x that is equal to cosine square x is strictly decreasing on for all x belonging to the interval 0 to pi by 2. So now in order to prove that this function is strictly decreasing on 0 to pi by 2, we'll take help of derivatives. Suppose we have a function, say y is equal to f of x, which is defined in some domain d. Now the function f of x is said to be strictly decreasing if the derivative of f of x is less than 0 for all x belonging to this domain D, right? So if the derivative, that is dy over dx, is negative, then the function is said to be strictly decreasing. So here first we have to find out the derivative of this function. So now f prime of x is given by dy dx of cos square x, and here the derivative of cos square x with respect to cosine x is 2 cos x, and then by chain rule we have to differentiate cos x with respect to x. So we have 2 cos x, and here the derivative of cosine x is minus sine x. So we have minus 2 sine x cos x, and from trigonometric identity sine 2 theta is 2 sine theta cos theta. So here we have minus sine 2x. So the derivative of this function is minus sine 2x. So now here we are given this interval, that is x belongs to the open interval 0 to pi by 2. So we can also write this statement as x greater than 0 but less than pi by 2, right? And here we note that we have 2x, that is the angle is 2x. So let us multiply this inequality throughout by 2. So we have here 2 times 0 is 0. Here we have 2x, and here we have pi. 2 and 2 get cancelled. So from this inequality we can easily conclude that 2x belongs to the interval that is 0 to pi. And from trigonometry we know that we have the 4 quadrants, and here we have 0, here we have pi by 2, here we have pi, 3 pi by 2, and here we have 2 pi. So from here we can see that 2x belongs to this interval, that is 0 to pi. So 2x lies either in the first quadrant or in the second quadrant, right? And we know that the sine function is positive in the first quadrant and the second quadrant, and the sine function is negative in the third and fourth quadrant. So 2x belongs to 0 to pi. It implies that 2x lies either in the first quadrant or in the second quadrant, so that sine 2x is greater than 0 for 2x belonging to 0 to pi, right? So now sine 2x is positive for 2x belonging to 0 to pi. So this quantity, that is sine 2x, is always greater than 0 when x belongs to this interval 0 to pi by 2. So this term, that is the derivative, that is f prime of x, is now equal to a negative. Here we have the negative sign due to the derivative, and here sine 2x is positive, right? And the product of negative and positive is negative, right? So f prime of x is always less than 0 because this is negative. So f prime of x is less than 0 for all x belonging to 0 to pi by 2. So therefore, this function f of x is equal to cos square x is strictly decreasing on 0 to pi by 2.